Hi, guys. I think we're going to go ahead and get started. Welcome to Uniswap the Vampire Slayer, subtitle The Curious Case of Disappearing Vampire Attacks. So for today, I wanted to have a little spooky unicorn, and I asked Phil on our design team to give me a spooky unicorn. So this is what we ended up with, because the other ones were a little bit too spooky. Shout out to Midjourney for these unicorns. So if you remember nothing else from today, hopefully you remember this. But no, so today we're mostly going to be talking about V4, which you might have heard a little bit about. But who we are. I'm Sarah, and this is Alice. We are Uniswap Labs protocol devs. So we're going to give you kind of a cool narrative about V4, but we'll also dive into some of the technicals here. So kind of bear with us through that. Sometimes you can find Alice and I matching occasionally. Unfortunately, we aren't today. But besides that, yeah, again, we're developers on the protocol team at Labs, so we'll get a little bit technical, but yeah, bear with us. All right, so what are we talking about today? Really, the kind of overarching theme of this talk is about how Uniswap v4 is really going to be something we see as kind of fast-tracking AMM innovation by making kind of, making it easier to build on top of, and making it safer and kind of faster for developers to be able to kind of leverage the network effects of an AMM.
So, to tell you really the story of how V4 came to be and why we've designed it in this collaborative way that we will describe, we're going to go back in time, not to the future, but to the 18th of May, 2020, which is the day that Uniswap v2 launched on mainnet. There's a few things that people remember, particularly when they think back to the V2 era. It was known at the time for introducing on-chain oracles so that other DeFi protocols could plug in, get the price in a decentralized way, and also for various other improvements that it brought to the code over previous version of Uniswap. How did it do? Well, you probably know some of this already. It did very well. By the end of 2020, it had done nearly $60 billion of volume, and today, it has now done nearly $450 billion to date. One of the other things people remember about the Uniswap v2 era in time was, well, let's see if you can guess it. We've got PancakeSwap. We've got QuickSwap. And there's more and more. And there's more than just these. These are just a set of examples. There was a lot of Uniswap v2 forks, and people talk about them in a positive way, a negative way. There's a lot of discussion around forks and what they do for the ecosystem, but we want to talk about some of the positives of forks today. The reason people fork a protocol is because they want to add new features, they want to add optimizations. They see something in the original protocol that they want changed for some reason or in some way. And that's innovation. It's how we improve on AMMs. It's how we improve on other protocols too. And it's seen people adding cool features that users want. And really, whether the liquidity and the volume moves between these AMMs is how you see, was that fork successful? Is this new AMM successful? Does it have the things that users are looking for? Are there any downsides to forks? Well, there's a couple, but one I want to touch on today is security. When you fork someone else's code, you might touch one area of the code with your changes, and it might affect another area of code without you realizing it because you might not know the original code 100% well. And there'll also be nuances in that code of decisions that the developers have made that you might be unaware of that might lead to you ending up introducing a bug by accident. So we've got a couple of examples. The first example is a router that was a fork of Uniswap that added some cool new features, but they accidentally removed a check that the caller of their router was a pool, a legitimate pool of their protocol. And what that actually meant was that anyone could, through sort of jumping it through loops, could take any user's funds that had been approved on that router. A second quick example is a fork that tried to add some farming of rewards for liquidity providers. And so they added some logic around how LPs get their rewards, and they accidentally made it so that LPs couldn't get any rewards at all in their fork. We don't want to sort of stress for a long time on these security issues. Forks can do amazing things and innovate, but they can also increase risk. And we'll jump back to why we've talked about this a bit later, but yeah, that's all we want to say about forks today.
Great. So fast forwarding now to May 5th, 2021, Uniswap v3 comes out. This is a really kind of breathtaking moment for AMMs. And what people might remember from this is the kind of introduction of concentrated liquidity. So, this innovation really gave LPs this new kind of expressiveness to where they could provide liquidity on that kind of price range. And how did Uniswap v3 did? Also, really well. In the first week, there was 10 billion in volume, cumulatively around 1 trillion in volume. And just to kind of give a quick kind of pulse check on really this power of concentrated liquidity, on the left here, we see a snapshot of TVL and volume on V2. On the right is V3. And what you can see is even just a few months after liquidity had migrated, V3 is doing triple the volume of V2 with half the TVL. So really, really powerful kind of level of expressiveness that also was able to give swappers some price improvement. But the talk is not about V3. You can go read the white paper. It is absolutely 9 pages of magic and sorcery. And really, I highlight this because there was a lot of really opinionated, design decisions in building V3. And today I want to highlight 2. Obviously people remember concentrated liquidity, but there are lots of other changes from V2. 2 of those changes I'm going to talk about are the Oracle and then fee tiers. So let's start with the Oracle. What changed with V3 Oracles? First is that it is a geometric mean oracle. So in V2, you saw an arithmetic mean oracle. Won't get into the details here. Basically, the point is that there's lots of different kinds of oracles. Different projects might have different opinions about what the best oracle, on-chain oracle is. And V3 enshrined this sort of geomean oracle. What else changed? So in the Uniswap v3 code, there are saved and shared accumulator values that are used by integrators that want to build an oracle. And so when I say shared accumulator values, that also means that there is some kind of shared cost put onto swappers of actually going and updating these values every time a pool is touched. And just some little kind of quick math here. The Oracle gas overhead is conservatively around 5,000 gas every block. If we assume that a pool is being touched on every block in a year, that's around $700,000 in gas overhead. And mind, as a reminder, this is per pool. So oracles might not even be used on certain pools, and so that is just kind of extraneous cost being put on the swapper. The second thing I want to talk about with V3 is fees. So it was quite an opinionated decision, not only to move away from just one fee tier in V2, there are now 3 different fee tiers. So we have 5 bips, 30 bips, 100 bips. And then on top of this, there was also the option that enabled governance to add a fee tier to the protocol. So, one, it was opinionated because there were 3 tiers, and then also it was very opinionated that it was these 3 tiers. And what ended up happening is that governance actually voted to add a 1 BIP fee tier. And that vote passed, and it ended up being, really successful for the protocol. You can see in just a matter of days, if you look at the blue here, that Uniswap v3, the market share shot up a lot, making Uniswap, very competitive in these stablecoin markets. And so the funny thing about this is that actually some early contributors and even Hayden himself thought that the 1-bit fee tier was not going to be successful and not worth putting into the protocol. And so, I bring all this up because I think, from what we've learned of seeing with V2 and seeing kind of forks, and then also seeing some of the opinionated decisions going into V3, we learned that the design space of AMMs is huge, and that, there are tons of decisions and opinions being made and built into these AMMs. And what we're here to kind of talk about with you more today as we dive into V4 is that kind of innovation happens when you push the boundaries of these opinions and you kind of poke and prod at what, kind of the structure of AMMs.
So that brings us to a much more recent date. June the 13th, 2023 was the day that we released the V4 code on GitHub, a lovely V4. There is also a white paper. It's hopefully a little bit less scary. It goes into what we changed from V3, what we've built on, and how we're trying to make V4 an ultimate platform of collaboration, of the whole world being able to innovate on what an AMM looks like, and helping make these decisions in an open source way. So what has changed with V4? Two main things we're going to be talking about now is, one, that it is highly customizable and flexible. We provide the base logic in the code, but people can customize it in an amazing way. And the second thing is a couple of big architectural changes that we've made to make it more efficient and to make it even better as a platform for people to build upon. So those are the two things we're going to touch on now.
Great. So diving into the first point, just about kind of the customizability of V4. How do we do it? We do it with hooks. So you might have heard this term. A hook is really just a smart contract that is attached to the pool when a pool is created. And to kind of see how hooks enable this customization, let's go back and kind of think about what are the various actions that kind of exist on an on-chain pool. So one, there's pool creation that I just talked about. There's obviously swapping one token for another. There's kind of the LP side, adding, removing, changing range. And then newly with V4, there's kind of sending money to in-range LPs. So yeah, all of these different points are various ways to interact with the core underlying protocol. Hooks play a part by interacting before and after each of these points on a pool. And again, hooks are this sort of external contract, and at each of these points, that code is going to be run. And we'll kind of look at an example of what that might look like. So if we have a hook that has the before swap and after swap kind of callback enabled, it's going to go through this diagram, starting the swap, checking that before swap flag, running the external code, coming back, finishing the core swap logic, checking the after swap, running the after swap arbitrary code, and then finally ending the swap. And so this is a really powerful primitive because it allows hooks to be able to really enshrine logic directly into the pool. So let's look at an example. This is just kind of a naive example, but on V4, you can actually create pools that are enforced full range liquidity, so something like a V2 style pool. So in this example, we look at the before modify position hook callback. It's actually just a few lines of code. All we have to do is check that the tick lower and the tick upper for when you provide liquidity are the min and max tick. That means liquidity is going to be spread across the entire price range. And if that's not true, we just revert. And so you're not able to add liquidity unless these params are true. And so, this is kind of a naive example. There's obviously a lot more you can do here. But this is going to be executed before any kind of liquidity is added into the pool. Great. So I wanted to quickly touch on a cute little implementation detail with hooks. Essentially, these callbacks that I just talked about, kind of the before and after swap, before and after modify position, they are all determined by the hook address. So we'll kind of look at what that means. This is a little bit of garbage right here, but this is the code in the core protocol. So these are all the flags that we have enabled for the various hook callbacks that I just talked about. Let's say, to give a little deeper of an example, we can say that this is some address that we have deployed a hook at. It's the address that we're going to use to initialize the pool. What's happening under the hood is we're actually looking at the first byte of the address, so this 20. We can see that translates to binary, to this value here, where there's a bit enabled at the third position. And that means that the pool has a hook at the before modify position flag. So we would use this address to kind of do this example that I just went over a few slides before. And what's really cool about this is, yes, it's a cute gas optimization, but what's great is that when you initialize a pool, you cannot change the points that a pool calls back into the hook. So those are immutable at pool creation time. So that just means that we can hold certain invariants about a hook and about a pool for the rest of its lifetime. So all that is to say is that hooks really allow you to build any kind of pool that you want. So we just went over kind of this enforced V2 style full range pool. You can build limit orders. You can build all kinds of oracles, yield bearing hooks. I mean, just really everything. And switch. Really, I want to emphasize though, at the core, you still get this same simple V3 style swap. So hooks are totally optional, and they just really allow more things to be done at the protocol.
Hello. So hopefully at least some of that made sense, and if you take away anything, it was that we've tried to put in ultimate flexibility, but maybe you're thinking, having all that extra logic, all those extra checks, that sounds like it must be expensive. Well, it can be more expensive, and we've tried to counteract that and offset that with some architectural changes that we've also made to the code. So we're going to go over two of those now. One of them is a singleton contract, and the other one we call flash accounting. So in a traditional DEX setup, you have one pool for each token pair. So if you want to trade USDC for WETH, that's one pool. If you want to trade Uni for DAI, that's a different pool. And those are different smart contracts. And that means, let's say you want to trade USDC for DAI, but the best possible price you can get at this moment, you need to trade via WETH. And that happens in the background in one transaction. But what happens is USDC gets sent in at the beginning of the trade. WETH has to get sent from one contract to another contract, and then DAI comes out at the other end of the trade. And this WETH transaction in the middle, this transfer, costs thousands of gas to move the WETH from one contract to another. The second expensive thing about this traditional setup is that when you want to set up a new pool, let's say there's a token, it's not yet on Uniswap, you want to set up a new pool for that token and WETH, you have to deploy a whole new smart contract, which can be a very expensive thing to do. So that's quite a big barrier. So now we have a singleton contract in Uniswap v4. All of the pools are within one smart contract and all managed separately within there. And that means that when you do one of those multi-hop trades that's trading via another asset, no tokens need to be transferred. And that saves a lot of gas. And then an even bigger gas saving is when you want to create a new pool. This little bit of code gets executed. All it does is store some initial values of the pool, and it's 99% cheaper than it was on v3 to create a new pool, which is awesome. So this singleton contract allows us to do greater things, and the one in particular that we love is something called flash accounting. Maybe some of you have heard of flash loans, where you can have an atomic transaction where if at the end of the transaction someone hasn't paid back their loan, the whole thing reverts, and it's like you never gave them the loan in the first place. So with Flash accounting, at the beginning, users acquire a lock on the contract. They can then perform any number or combination of actions, whether that's swapping between different pools, that's adding liquidity. And the singleton contract tracks all of the tokens going in and out of the contract overall using this currency delta. And then at the end of the transaction, when you're finished with your actions, the contract checks if you've paid all of your debts and you've taken out all the tokens that you were meant to take out. And if you haven't, then the whole transaction reverts and it's like it never happened. And if you have paid them, then great. Here's a quick example. So the user acquires a lock, and that sets up your lock accounting. You want to swap one WETH for USDC first. So the user owes one WETH to the contract, and the contract owes the user 1,800 USDC. Now the user wants to swap 1,800 USDC for DAI as like the second hop of that trade. Well, the user owes 1,800 USDC and is owed 1,800 DAI. And those two USDC on either side can cancel out. So it's like the user never has to know that that was going on. And this is the final balance of that trade. So you can now withdraw the DAI you're owed. You can pay the debt of your one WETH that you wanted to trade. And you can release the lock. And woohoo, you paid all your debts, so the transaction succeeded. And that's, at a high level, what Flash accounting can do in v4, and that's enabled by this singleton model that we have. The best way to do this is through something called transient storage, which a lot of you may not have heard of. It's an EIP still at this moment called 1153. And what it does is it's storage values that are specifically only going to exist for the duration of a transaction. They're 0 at the beginning, they're going to be 0 again at the end, and so you can make that guarantee that no one's ever going to have to actually store those values at the end of the transaction. And that allows us to make the code much cleaner and much cheaper from a gas point of view. This EIP is, as I said, not yet on mainnet, but it is slated for the Cancun fork, which should happen at some point. So why does all of this matter? Everything we've been talking about. We talked about forks and how they allow people to be so innovative. And in the same way, with V3, people around the world had thoughts that they wanted to change about V3. And for some cases, they did through governance, and through others, it was conversations that were had. But there's so many opinions out there of how things should be, and we wanted to maximize the way in which the entire world as a community can build what the future of an AMM looks like. And V4 hopefully encourages AMM innovation through this infrastructure that we've built. So hopefully this is what the future of V4 looks like.
Okay, just to kind of go over a little bit of the timeline here. V4 is still in development. We released the code about 1 month ago. There's already been 100 issues and pull requests opened, which is really awesome to see. We've gotten some high quality contributions. What's also really cool to see is that there's already 30 contributors on the repo with merged code. And just as comparison, V2 had 7. So really kind of embracing this sort of collaborative effort and kind of pushing the next AMM forward. And just to highlight a few really cool feature ideas from the community, these are 2 specific ones, kind of a pool no-op for hooks and arbitrary and kind of arbitrary data passing to hooks. These are really, really cool because they kind of open up a whole new kind of use case category for hooks, something that we hadn't thought of. So kind of shout out to these community members for these ideas. Also, as expected, this protocol is still in development. There are bugs to be found. This was a really great submission from someone in the community, and helped us find these bugs quicker so that we can fix them. So yeah, come build with us. Check out the repo. We have a few different repos for V4 on GitHub. We'd love to hear your thoughts. Submit PRs and issues. And also, we'll be around today. There's a few other talks by a few other Uniswap folks today, and we'll be walking around. So if you have questions, come get us. And yeah, thank you so much.